All right, let's dive into something that's at the absolute core of cybersecurity, something that both the good guys and the bad guys do every single day. We're talking about network scanning. Think of it as casing a digital joint, and it all starts with finding an open door.
You know, it really boils down to a pretty simple idea. Before a burglar tries to get into a house, they don't just run up and kick the door down. No, they do their homework. They walk the perimeter, they jiggle the doorknobs, they peek in the windows, they're looking for weaknesses. Hackers do the exact same thing, just in the digital world.
So, let's put a formal name to this digital snooping. What exactly is network scanning? Well, it's really the first active step an attacker takes when they're trying to find a way into a target network.
At its heart, network scanning is all about answering three big questions. First, who's actually on this network? Second, what are their digital doors and windows? We call them ports. And are any of them unlocked? And third, what's actually running behind those open doors?
This little diagram here shows you the basic flow. Now, don't get too hung up on the technical details. The key takeaway is super simple. An attacker sends out a bunch of messages, we call them probes, to a network. And the way that network talks back, or sometimes the way it doesn't talk back, gives the attacker a goldmine of information.
So the very first question, the absolute starting point for any attacker, is incredibly simple. Out of all the millions of possible addresses on a network, which ones are actually plugged into a live computer? In other words, is anybody actually home?
Imagine a huge neighborhood with, say, 10,000 addresses, but only a few hundred actual houses are built. You're not going to waste your time checking the locks on an empty plot of land, are you? Of course not. Host discovery is just that. It's finding the houses with the lights on so you can focus your attention where it actually matters.
And to do this, attackers have a few go-to tricks. A ping sweep is basically like shouting Marco down a whole street and waiting to hear Polo back. An ARP scan is more like walking down the block and checking the names on the mailboxes. It only works if you're already on the local network. And TCP/UDP scans? That's kind of like dialing a few common phone extensions for each house just to see if anyone picks up.
Okay, so you found a house with the lights on. You know someone's home. What's next? Well, now you start checking the doors and windows. In the digital world, we call these ports.
And this right here is why it's so important. Every single open port is a potential way in. Think about it. A web server needs port 80 open. An email server might need port 25. Each one is a service that's offered to the world. And the more services you're offering, well, the more chances an attacker has to find one that's weak.
Now, to really get how attackers check for these open ports, we have to look at how computers politely introduce themselves. This diagram shows something called the three-way handshake. It's pretty much the digital version of, "Hi, can we talk? Sure, I'm listening. And awesome, here's what I wanted to say."
Let's break it down really quick. First, your computer, the client, sends an initiation request. That's a SYN packet. If the server on the other end is listening on that port, it replies with an acknowledgement, a SYN-ACK packet. And finally, your computer says thanks with one last ACK packet, and boom, the connection's open. SYN, SYN-ACK, ACK. That's the polite way to do it.
Okay, so we found a live computer, and we know which of its doors are unlocked. Are we done? Nope, not even close. A real pro doesn't just want to know the door is open, they want to know exactly what's hiding behind it.
And this is absolutely crucial. See, it's one thing to find an open door, but it's a whole other level to find out that that door leads to a server running a version of Windows from 10 years ago with a dozen security holes that were never patched. That's the jackpot. And this whole process is called fingerprinting.
Attackers have some really clever tricks for this. For example, every chunk of data sent over the internet has something called a time to live, or TTL value. It's basically a countdown timer. And here's the cool part. Different operating systems start that timer at different numbers. So by looking at the TTL value that comes back, an attacker can make a really good guess. If it's a number close to 128, it's probably a Windows machine. Close to 64, almost definitely Linux.
So far, this might sound a little too easy for the attacker, right? But here's the thing. We're not alone in this story. Every modern network has digital security guards, things like firewalls and intrusion detection systems, and their entire job is to spot and block exactly this kind of suspicious snooping. And this is where the real cat and mouse game begins. A basic scan does that full, polite three-way handshake we talked about. It works, but man, is it loud. It's like knocking on the door and shouting your name. The firewall logs everything. A stealthier method, what's called a half-open scan, is more like a digital ding-dong ditch.
It sends that first hello, here's the I'm listening reply, and then immediately hangs up before the conversation gets logged. It's sneaky and often slips right past the guards. But for the ultimate in stealth, attackers can use a technique that is truly mind-bending. It's called an idle scan. Now the details are pretty complex, but the idea is pure genius. They find a totally random, quiet computer on the internet, they call it a zombie, and they bounce their scan off of it to hit the target. The attacker can figure out if the target's ports are open without ever sending a single packet to the target directly. The attacker's real address never ever shows up in the victim's logs. It's like being a ghost.
And that, right there, is the heart of the matter. As attackers come up with stealthier ways to scan, defenders build smarter systems to detect them. It is a never-ending cycle of offense and defense, with both sides constantly trying to outsmart the other.
And that cycle is spinning faster than ever. You know, it used to be that you had to memorize all these complex, cryptic commands to run a good scan. But now, attackers can just use AI. They can literally ask a tool like ChatGPT to run a stealthy scan on this network and tell me what you find. It makes these incredibly powerful techniques available to just about anyone.
So after all this talk about attackers and burglars and zombies, you're probably thinking that scanning is only for the bad guys. But this is where the whole story flips on its head, because the best cybersecurity pros, they think just like the attackers.
Look, if there's one thing you take away from all of this, let it be this. To properly defend your house, you have to think like a burglar. To secure a network, you have to know exactly how an attacker will try to break in. The path they take is the same path you have to walk to find your own weaknesses.
The good guys use these exact same scanning tools every single day. They scan their own networks to find old, forgotten ports that were left open by mistake. They scan to find old software that desperately needs an update. They even scan to test their own security systems to make sure the alarms are actually working. They are playing the part of the attacker so they can find the weak spots first.
Because in the end, every single device on your network, your phone, your laptop, your smart TV, your doorbell, every one of them is a potential door. And the real question is, do you know who's checking the locks? Thanks for joining us.